I know most people sign on to check out my energy saving battery videos, etc. But today I'm doing something a little different. I'm just gonna give you guys an update on the current myosensor technology, which is muscle interfaces for prosthetics. Now what's happening here is there is a myosensor connected to my arm. I'm kind of mimicking something called a mantis blade from a game coming out recently, but that's just for fun. This guy is actually controlled by my muscle. If I give it several strengthening pumps, one more should go. Yep, and as you notice, it closed there. There's also some jittering on my cheap servo motor. Yep, so I have these two servo motors and an additional third one controlling the blade itself. I'll be increasing tension at some other point, probably switching out to a different style of motor. Let's check out my code real quick. For those who care, don't worry, it'll be pretty quick. This is the code. Let's hope let that clear up in a second. Maybe if I zoom out, it might help. This is essentially my code. It's fairly simple, straightforward code. It's literally less than a page. I try to keep my code short for this because people hate that. And this is my graph that's recording my muscle activity in my arm. When I flex, yep, you heard that guy trigger, and you get a spike. I have it set up so it reads for 4 flexes, and then activates. So I'll let you watch that on my arm. I have a detector there. You can see the amount of flexing I have to do. You can set it as high or low as you want. It's all in the code. But yeah, this is kind of the current home standard, I guess, for people who are interested in prosthetics and want to do it at their own house. It's called a myaware sensor. Well, this is a myaware sensor. There are various sensors of this type you can find on Amazon, whatnot. They're all around the $30 price point. I'm getting several more of these pretty soon to do a larger interface. Anyways, you know what? You guys are typically great at giving advice. So I kind of want to ask you guys, what do you think I should do to change this up for the, of course I need to taper the arm, right? Different servo motors probably, if you guys know of cheap ones that are decent. Don't worry about the cutting here. This was literally just to put it together. I need to do a lot of sanding. My hinges are horrible. Probably some sanding, some painting, but I didn't want to do all that work on this guy considering I'm replacing him with a tapered arm at some point. The code again, so you can check it out. Hopefully it's clear enough. If anyone has advice on that, of course, I'll take it. I have, a couple ideas myself, but I'll keep that to myself so that we can get some discussions going on it. And that's the graph. She freezes sometimes because I have the this guy, which takes, what does he take? I think he takes like 500 milliamps by himself. And the computer USB ports are usually about only 500 milliamps. So whenever he triggers and something else triggers at the same time, it can mess up the graph or the readings, the serial readings going back and forth. So don't worry too much about that. Again, I'll show you from a distance. Ignore all the plastic on the ground. There's a lot of work going on here. 2, 3, and one more. Go. There you go. There you go. Back out. I gotta put this in tighter. I'm using a Arduino, which they're freaking awesome. You should look into them. They're great. Again, this is kind of a mantis blade style. Yeah, she keeps her setting to the default position just because she's drawing so much power from the computer. I do connect it to the wall, and I can power up a battery, but I don't want to hook up a battery right now because I kind of want to get the serial reading as well. Give me a second. So I'm guessing what I'm really asking for. Yep. So again, the default position is kind of like a limp noodle with it at probably 30 degrees each. There you go. Actually, it comes up, and if I flex again, it actually tucks in an order because I have to make sure for several reasons. One, because it closes neater, and another one is the fact that if I have this guy activated along with another motor, it can cause issues. Again, because of the amperage draw. Yeah, I want recommendations for the hinges on the arms, the hinge on the blade itself, the mechanism to return the blade to position, because right now it's using gravity, but I can use springs or whatever. There's a little bit of tension on this line here, but that's not much. That's actually to keep it from overextending too high up. So hinge advice. Hinge advice for this portion right here as well. You can design it and send me or comment below if you want to send me a STL file or another type of file for your 3D prints. Servo motors I always want advice for. The bracing, whatever you want to talk about, whatever shape. If you think the door design could be better, or fancier, or simpler, I'll probably be making a bunch of these based on what you guys recommend. Okay. Don't do drugs and do drugs if you want to, I guess. No, you shouldn't do drugs. Take care. Comment below, give me advice on this and what you think I should do with it. I have a bunch of other sensors come in. Again, this is the current standard for like at-home practitioners of prosthetics. Again, it's all muscle controlled sensors. These are typically the cheapest servos you're gonna find around. These are the cheapest. What are these? 9 grams, probably 9 or 15 grams. And this guy is I'm not quite sure. I think it's actually a few kilos. But again, this guy alone is probably like $4. He was more expensive than probably 5 of these smaller ones. But, it's more convenient to use. And he has a larger draw. Advice on any of that, especially if you have a source of better servo motors that could be used. Thank you. Take care. Comment below. Oh, and subscribe if you want to know whenever I make other crap, or whenever your ideas might be put up. Take care.